Alright, this is my video on limits at infinity. It's, again, the same idea. This is, by the way, if you don't remember, I made a video on the nth term test, and it's the same thing. The nth term test pretty much uses the limits at infinity principle, because you are taking the limit as n approaches infinity. But it doesn't matter, So, limit, I'm going to show 3 different ways of thinking about this. It's not necessarily different methods, it's just 3 different ways of doing it. That I'll show you the way I usually do it, so let's rewrite it. It's the limit as x approaches infinity. Now what you do, you recognize the highest power term in the whole thing. You look at the numerator and you're like x squared, x to the first, x to the 0. Alright, x squared's the highest. And let's look at the denominator, x squared, x to the first, x to the 0. Oh, x squared's the highest yet again. And yeah, good times. So you know what that means, right? That means we divide every single term by x squared. I'll illustrate it here. So it's 2x squared over x squared plus 3x over x squared minus 1 over x squared over... This is the way I usually do it. It helps me understand it because look at this. Cancel. Cancel. And then this is 7x squared over x squared minus 9x over x squared plus 72 over x squared. Alright, cool. And these guys cancel too. So now let's rewrite it. It's the limit as x approaches infinity. Now this is going to be rewritten as plus 2 plus 3 over x minus 1 over x squared over 7 minus 9 over x plus 72 over x squared. Now if you remember from my last video, constant coefficients don't make a damn difference in determining the limit. If the highest degree term is in the denominator, goes to 0, goes to 0, goes to 0, goes to 0. Which means that we can rewrite this limit as the limit as x approaches infinity of... Well, no, I've already done it. Sorry, that's wrong. What I've done here is I've already evaluated the limit. I've plugged in infinity. I've plugged in infinity here, 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 and here. And I've recognized that it goes to 0, which means I'm left with 2 over 7. So that's it. It approaches 2 over 7. Now I'm going to show the second way of doing it, which is the way that I did in my last video. It's the limit as x approaches infinity. And by the way, this way that I'm doing right now is probably a lot more safer because it's you can use it when you're doing it's basically factorizing. So I'm going to rewrite the exact same problem as I had before. So 2x squared plus 3x minus 1 over 7x squared minus 9x plus 72. Cool. So what do I do here? Well, I'm going to factor out the highest degree term. The highest degree term in the numerator is x squared. The highest degree term in the denominator is also x squared, which means that I can rewrite this as the limit as x tends to infinity. I made the switcheroo on you yet again. I am very cringe, by the way. So now this is factored out. So 2 plus 3 over x minus 1 over x squared. As you can see, sorry, that just went through my term. As you can see, this is like almost the exact same things I had up here, but this is like, you know, a bit cleaner, I guess. And this, I factor out the x squared again. 7 minus 9 over x plus 72 over x squared. Cancel, cancel, because they're being multiplied, which means I can cancel them out. And then, what do you know? I evaluate the limit yet again. It will be 2 plus 3 over x minus 1 over x squared, which is also equal to 2 over 7. Same answer as up here. But I'll show you the coolest thing that you can do with this trick. You can look at the expression and say, what's the highest degree term? Well, I know it's x squared, I know it's x squared. Now, what are the coefficients on those terms? 2 over 7. And you don't even need to do any of this algebra. All you need to do is just look at the coefficients of the highest degree terms, and that's where your limit will be. That's where your limit will approach. So those are the 3 different ways of thinking about it. So you can use my way for simple kinds of expressions, and you can use this way if you want to like do factorizing where you've got like let's just say you've got like x to the 3 halves and stuff like that, and it gets a bit more complicated than just, you know, oh, let's divide everything by the highest degree term. Anyway, that's the end of the video. This is Limits at Infinity Part 2, so from now on, I think I'll start making videos on actually evaluating different kinds of limits at infinity. Obviously, you get the idea now, but I'll show even harder examples. And yeah, that's pretty much it. Cheers for watching.